Hello everyone, welcome to the Mechanical Engineering 1. Today I will show you how to solve one dynamic problem, which is very easy one, by systematically way, and why it is so important to learn how to solve one engineering problem in systematic way, and make a good assumption before you start solve the problem is because after this course you have to study engineering thermodynamics and the fluid mechanics, and you won't learn them together in one semester, but you will learn in one academic year. So which means you cannot solve one engineering problems by using both of thermodynamic theories and fluid dynamic theories together at the same time, and at that moment you have to make assumptions to make the problem easier to solve. The problem I pick is from this book, which you are recommended to buy in this course. Okay, let's start looking into the problem. So what we are given in the question here is we know the mass of the plane, which is 40 megagram, and we convert it into a kilogram, which is 40 times 10 to the power of 3 kilogram. Yep. It's very important every time you pay attention to the unit here. You have to convert them to the unit you want. Otherwise, the final results will usually very quite different from the correct answer. So the velocity, and we also give the velocity of initial of the plane, which is 650 kilometers per hour, and we have to convert it into the 180. I have done the calculations already, so I just read the answer. But if you have got any questions how to convert this to this, I think you won't. It should be divided by the 3.6, and also we have the angle of the elevation of the plane, which is 5 degrees, and the velocity after 120 seconds, which is equal to 600 kilometers per hour, and we have to convert into the SI data, and it's 166.67 meters per second. And what's the question the problem is asked is which required is the time average drag force along the fly path, and we domain is D. And okay, so here is what we know, and here is the problems we have to find out. And now, after these two, the most important part is we have to make an assumption. Oh, sorry. So if you want to run the fly path, we have to make assumption. Let me zoom out a bit. Assumptions. So first of all, we are asking to find the time average drag force. That means the airplane, the acceleration should be constant. And we also have to assume there is no other force except the gravitation, the force due to the gravity, and the drag force. Of course, because we are asking to find it. And because the airplane is actually in very high altitudes, and we don't know how high it is, so we also have to make assumption which the acceleration. Oh wait, sorry. Due to the gravity is 9.81 meters, and it remains constant. Why we have to assume it remains constant? Because the airplane, as you can see, the velocity is quite high speed, and the altitude is actually change a lot. But because we have to make it easier to solve this problem, so we have to make a assumption in which the acceleration due to the gravity remains constant. Okay, so after all, we got our given require and assumption. We can start to solve our problems. So it's always good idea to start with FBD. And what is FBD is free body diagram, and we have to analyze the airplane. So here's horizontal line, and here's a vertical line. The airplane is this is the flight path. The elevation is 5 degrees here, and the airplane, there is a force due to gravity acceleration, so mg, and the drag force, which we are going to find out, and that's all. So if you don't have a good assumption here, you probably have some side winds, or the winds from the below or up the plane, so you have to analyze them one by one, and you will in troubles. So we got the free body diagrams, and the let's have the equation we are going to use. So equations is very easy ones, which is Vf is equal to plus At, haha, and the results force is equal to the MA, the Newton second law. And you should be very familiar to these two formula. And okay, so the solution. So basically it's just submit what you know up here to the equation down here. So we already know the final velocity, which is 166.67, and is equal to the initial velocity plus the acceleration times the time duration. So why I put a bracket here is because you will have many engineering problems using vectors in future. So in that case, you will put a dot product and the cross product in your paper, and I use the bracket to distinguish them, so it makes me read them much more clear. But you can find your ways anyway. And so we have, after this we got the acceleration, which is equal to 0.1158 meters per square second. And because the accelerations here is actually the velocity, sorry, excuse me, it's a velocity along the path. So after 120 seconds, the airplane probably just moved to here, and the velocity is pointed to the flight path. So the direction, because it's a vector also, so the direction of the acceleration here is along the flight path. Great. So we know the acceleration of the path is equal to 0.1158 meters per square second, and the minus signs here is means the acceleration is opposite to the direction in the airplane moving to. So the airplane moving in this direction, so the negative sign should be in this direction. Okay, so then we can submit the acceleration into our second equation, which is Newton's second laws, and will be the R equal to mass, which is 40 times 10 to the power 3, and times the acceleration, which is minus 0.118. And the reason I use cross here, because they are all numbers. There is no other things in these equations, so that's why I use cross here. And we easily find the result force, which is equal to minus 4.632 times 10 to the power 3 Newton, and then the direction is along the flight path. Okay. Okay, and so we now know the results for along the flight path here. So we just need to know what's the components of the mg in the direction of the flight path. So mg here, r is actually equal to mg times sine 5 degree plus drag force, and obviously the drag force is equal to negative, so here should be minus anyway, so but we already know the drag force should be negative, and we know the result force is equal to minus 4.362 Newton, and we submit the mg sine 5 degree, and we already assume that acceleration due to the gravitation is equal to 9.81, and it remains constant, so we can substitute the mg here, and we got d is equal to 38.8 kilonewton minus, and the minus just show the direction is opposite to the velocity, the direction of velocity, and the magnitude is 38.8 kilonewton. So that's all of the problem, and let's have a review of the whole problems again. So we got a very easy problems, assume, and we write down the given, what the given from the question, and what's the question asked about. Then we have to make some assumptions. So because of these assumptions, we can start to solve the problems in a very easy way. And the assumption, this part sections is very important part, and it's very useful in your future. So for this question, we have three assumptions, which is acceleration is a constant acceleration, and no other force except the gravitation force and the drag force due to the wind, and the acceleration due to the gravity is 9.81, and it remains constant here. So the assumption probably is the most important part of all the solutions. So after the first three parts, we are starting to look into the problems. The free body diagrams is make your life easier to analyze the problems. So we from the diagrams we can very clearly see the mg is not along the flat path, and so we have to find out the components of mg project on the flat path, and then we can find out the result of force here. And here is just we write the equations that we might use. You don't really need to write everything you need, because you probably think up some things later, but write up some equation here where keep reminds, okay, I know these equations, I just need to submit some numbers from the givens to here, and we can solve the problem easier. So the equation just to help you solve the problem. So it's not quite necessary, but still very useful, helpful. So here it just submits the numbers, and we finally find the magnitudes. And that's all. Thank you very much.